This is Lesson 8-2C from your Algebra Readiness textbook. To begin today's lesson, you'll want to pause the video and work the study guide problem. Continue the video when you're ready to compare your answer to mine. As a review of our previous lesson, you are being asked to graph the equation y equals negative 3x plus 4. The best way to graph an equation so far has been to make a table of x and y values. While you can choose any x value you want, I find it easiest to choose the values of negative 2, negative 1, 0, 1, and 2. This allows me to see the graph to the left and to the right of the y-axis, and their numbers are super easy to multiply in my head. So the way that I solve this then is to substitute the numbers into my original equation and get an answer. Okay, so negative 3 times negative 2 plus 4 gives me positive 6 plus 4 is 10. Then negative 3 times negative 1 plus 4 gives me 3 plus 4 is 7. Negative 3 times 0 plus 4 gives me 4. Negative 3 times 1 plus 4 gives me 1. And then negative 3 times 2 plus 4 gives me negative 6. Negative 6 plus 4 is negative 2. Some of you have brought up or have noticed that these numbers are going up by adding 3 each time. And that is a very real pattern. And some of you have said, well, once I know the pattern, can I use it? And the answer is sure. You bet you can. Now I've got an ordered pair. A table is a list of ordered pairs. The first ordered pair is an x value and a y value, and so the x value is negative 2 and the y value is 10. The next ordered pair is negative 1, 7, 0, 4, 1, 1, and 2, negative 2. Now you graph these ordered pairs on your number or on your coordinate plane. Negative 2 goes back 2 and then up 10. And place your dot. So an ordered pair is like a road map or directions on how to locate this point. The next ordered pair is negative 1, 7. So I go starting at 0, I go back 1, and then I go up 7. The next ordered pair is 0, 4. And the next ordered pair is 1, 1. And finally, 2, negative 2. Okay, the next question asks me, what are my domain values? Remember, domain values are your x values. It's just a list of your x values. So capital D for domain, and then I just go along and write these down in order. So I write negative 2, negative 1, 0, 1, 2. Those are the domain values in that table. What are the range values in the table? So my range values are my y values. Make sure you memorize that. And my range values then are 10, 7, 4, 1, and negative 2. Is the graph linear or nonlinear? When you look over here at the graph, I see that the points connect in a straight line. Straight line graphs are linear because the graph makes a straight line. And lastly, is the graph a function? If I had a pencil and the pencil here's my attempt at a pencil. And I took this pencil and I dragged it along to see if it overlapped any of the points or the line overlapped the pencil at more than one spot on my pencil at any given moment. And it doesn't. So also I can look at my range values. My domain values. Do any of my x values repeat? No. none of them repeat. And so I would say, yes, it's a function because x values don't repeat, or because graph passes the vertical line test. Okay, so that's what we learned so far, and what we're doing today is not much different. In fact, what we're doing today is very, very closely related. We are going to graph linear equations, but this time we are going to graph linear equations that involve fractions. Now, don't panic. It's not as hard as it seems. In fact, our very first step is going to be to get rid of the fraction. So then it'll be exactly like it was. Let me show you. So for the first one, if I were going to graph this equation, y equals negative 3 halves x plus 2 equals 6. Normally, I would tell you, all right, we're going to create a graph, a table, and we're going to use negative 2, negative 1, 0, 1, and 2. But I am going to tell you we're not going to do that this time. The reason is because these numbers are no longer the easiest numbers to multiply a fraction by. For example, if I use the number 1, yes, 1 times 3 halves is 3 halves, but then I still have 3 halves, this equals 3 halves, plus 6. So I get 6 and 3 halves, and I still have that fraction, and it's gross. Now compare that to, what if I use the number 4? Negative 3 over 2 times 4, and I'll use 4 over 1. Watch what happens. The 2 and the 4 have a common factor, so I'm going to simplify first. You don't have to. You could have multiplied across and gotten 12 over 2 and simplified 12 over 2. But I'm going to simplify first. And then I get 3 times 2 is 6 over 1, which is really negative 6, because don't forget about that negative right here. Negative 6 plus 6 equals 0. Do you see how the very first step was to choose a value for x so that my fraction goes away? And that's what your job is today. That's the whole lesson. So how do I know if the fraction will go away? The key is in the denominator. If the denominator is 2, I want you to choose numbers that are multiples of 2. So in this case, let's choose 2, 4, 6, 8, and you could choose the negatives of those. You could choose negative 2, negative 4, negative 6, okay? And the smaller the numbers, the easier they are to multiply. Now, I also always like to choose 0. In this case, I think that we could make this a little faster by doing negative 2, 0, and 2. Do at least 3 points. Okay, let's... All right, here we go. Y equals negative 3 over 2 x plus 6. What's the y value? Let's use negative 2. So I'm going to write negative 3 over 2. Then where x is, I'm going to put negative 2 in there, which is really negative 2 over 1 plus 6. Now these cross off. Negative 3 times a negative 1 gives me a positive 3. 3 plus 6 gives me 9. Now let's try doing it again, but this time let's use 0. Negative 3 over 2 times 0 plus 6. Negative 3 over 2 times 0 is 0. Fraction went away. 0 plus 6 is 6. Let's do another one. Negative 3 over 2 times 2 over 1 plus 6. Now I'm going to simplify. The 2's cross out. Negative 3 times 1 is negative 3 over 1, which is really negative 3. So this whole part equals negative 3. Negative 3 plus 6 gives me a positive 3. All right, now I'm ready with my ordered pairs. My first ordered pair is negative 2, 9, 0, 6, and 2, 3. Okay, let's go. Negative 2, 9, 0, 6, and 2, 3. And then make sure you put your arrowheads. Is that a straight line? Yes. So we have a linear function. All right, let's try this one. Negative 1/2 x plus 3. Again, my denominator is a 2. We want to make sure that we stick to the idea when we're making a table of having at least 3 values in our table. Okay? So let's try. Here are my x or domain values. Here are my y values. And then I write the equation here. What values for x should I choose? Well, if the denominator is a 2, I know that I could choose 2, 4, 6, 8, and I can choose negatives of those. So I like to choose negative 2. I always like to have 0 in my table, and let's pick 2. So I'm counting by 2's. See how my x values count by 2's? All right, then let's substitute it in and solve. Negative 1 over 2 times negative 2 over 1 plus 3. So let's solve this part first. This crosses off, and I'm left with a positive 1. 1 times 1 on the numerator, 1 times 1 in the denominator. Negative times a negative is a positive. So I have a positive 1 plus 3 gives me 4. Then we write it again. Negative 1/2 times 0 plus 3. Negative 1/2 times 0 is 0. 0 plus 3 is 3. Negative 1/2 times 0 plus, oops, not plus 0. That one should be 2 times 2 over 1. This time, this crosses off and it equals negative 1 plus 3 is 2. Now I have my ordered pairs. Negative 2, 4, 0, 3, and 2, 2. Okay? Negative 2, negative 2, 4, 0, 3, and 2, 2. And again, well, my dot here is probably a little whatever, but again, I have a linear equation. Oops, I graphed it on the wrong one. I should have graphed it over here. There we go. Sorry about that. Okay, so that's my equation graphed. Is it linear? You bet it is. That is a linear. What are my domain values? These are the domain values. These are the range values. Is it a function? Do any of my x values repeat? Nope. If I drew a straight line and I asked you to draw it across here, do any of the points intersect my vertical line at more than one spot? Nope. So this is a linear function. Okay, let's try the next one. This time, I'd like you to pause the video, and I want you to try to do this one on your own. In looking at this one, I hope you notice that again my fraction has a denominator of 2. I need to use multiples of 2, including negative numbers and 0, so I go with negative 2, 0, 2. Then I plug the numbers in. Negative 1/2 times negative 2 over 1. And I end up with positive, well, this crosses off, and I'm left with positive 1. Then I solve it again. Negative 1/2 times 0 is 0. Then negative 1/2 times 2. Notice how I put 2 as a fraction. 2 over 1. And I get negative 1. Now I'm ready to graph. This ordered pair is negative 2, 1. This ordered pair is 0, 0. And this ordered pair is 2, negative 1. Negative 2, 1 is right here. 0, 0 is right here. and 2, negative 1 is right here. Still a linear equation. Hold on, I got to scooch that line down. There we go. And notice that this one is special because it goes right through the origin. And anytime that you have an equation that doesn't have anything being added, like here, this one added 3, if you have one that doesn't add anything, they'll always go through the origin. So that's just a little check for you. All right, one more time, I want you to pause the video. Try making a table and graphing this equation on your own. Make sure to take note that this denominator is a 4. So your x values should be multiples of 4. And make sure to include 0. All right, folks, you hopefully when you did yours, you set yours up like this. You may or may not have gone to 8. You maybe only did 3 points. That'll be fine. It doesn't matter. You can just do that. 4 equals 1/4 times negative 4 over 1. First thing we want to do is multiply by something that gets rid of the fraction. We end up with negative 1 plus 6 gives me 5. Solving the problem again using 0 for x, I get 6. Then solving the equation again, this time using 4 over 1, and I cross these off, and I get 7. Then I could solve for 8. Y equals 1/4 times 8 over 1 plus 6. And that equals 2. 2 plus 6 is 8. Now let's graph. The first ordered pair is negative 4, 5. So back 4, up 5. Then 0, 6. Then 4, 7. Then 8, 8. And here's my line. Make sure to put an arrowhead on either side. And I've graphed the line. Is it linear? You bet it is. Is it a function? Well, now we have to check these x values. Do any of them repeat? No. Or you could do the vertical line test. And it passes the vertical line test. So this is an example of a linear function. Okay? All right, this one. This one I'm more worried about just setting up the table. So let's pause the video, try to set this table up on your own, then come on back to compare your answers to mine. When I look at this one, I see it has a denominator of 5. So normally when I would have used negative 2, negative 1, 0, 1, and 2, because that's a fraction, I'm instead going to use multiples of 5. Starting at negative 5, 0, 5. I could go on to 10 if I wanted, but I don't have to. I need a minimum of 3 entries in my table. And so now let's begin. 3/5 times negative 5 over 1 minus 6. 3 times negative 1 is negative 3. Negative 3 minus 6 is negative 9. The next one, 3/5 times 0 is 0. 0 minus 6 is negative 6. Now let's substitute 5 in. And I get 3. 3 minus 6 is negative 3. Now, again, you could stop there, but if you like to really double check, go ahead and use 10. Any multiple of 5 will make that fraction go away. 6, 6 minus 6 gives me 0. Now let's start plotting these. Back 5, down 9. Zero, negative 6. 5, negative 3. And 10, 0. Here's my graph. Is that graph linear? If the points fall in a straight line, it's linear. What are my domain values? Negative 5, 0, 5, 10. My range values, negative 9, negative 6, negative 3, 0. Is this a linear function? You bet, because the x values do not repeat. And because it passes the vertical line test. All right, and for this one, we can, we're just going to set up the table for this one, and then we're gonna know that you can graph it. Again, I'm looking at this 2, so I go -2, 0, 2, 1/2 x minus 5. So 1/2 times -2 over 1 minus 5. And you get -1 minus 5 is -6. The next one, 1/2 times 0 is 0. 0 minus 5 is -5. 1/2 times 2 over 1, you get 1. 1 minus 5 gives me -4. And then you would graph. I think you're ready to give this a try on the 8-2C work.